history. In the 1950s, a major earthquake cost millions in life and property, which serves as a reminder to the world. Most recently, the Yellowstone region was rocked by hundreds of earthquakes and tremors. This got experts worried that a bigger event might be on the way. The general public has also become aware of the acute threat that the sleeping giant is to human existence. What caused the hundreds of earthquakes that hit Yellowstone? Could this be a sign that a bigger quake is coming? Would we survive a Yellowstone seismic event? Join us in this video as we uncover the Yellowstone National Park officials report that hundreds of earthquakes have hit Yellowstone. Located in the northwest corner of Wyoming, Yellowstone is the first national park in the United States. This sprawling park, which extends into Montana and Idaho, is known for its wildlife and many geothermal features. It also boasts a wide range of biomes, rock ranges, and forest ecoregions, among many others. Historically, Native Americans have inhabited the Yellowstone region for at least 11,000 years. However, organized exploration did not officially begin until the late 1860s. On the surface, this region has a tranquil outlook, but it is home to over 10,000 hydrothermal features, including geysers, hot springs, and fumaroles, making it the largest concentration of such phenomena on Earth. Beneath these breathtaking landscapes and natural wonders is a geological marvel that has captivated scientists and instilled awe in millions of visitors. This vast wilderness spans over 2.2 million acres and is more than a dream destination for pictures and vacations. It is a living, breathing testament to the raw power of our planet. It also serves as a way to study and understand the Earth's inner workings. At the heart of Yellowstone's allure is the Yellowstone caldera, which is a colossal crater formed by a supervolcano. Every 90 minutes to 2 hours, the caldera unleashes a high shoot of scalding water and steam into the air. This unique personality and eruption pattern are particularly captivating for visitors. Aside from the geyser, Yellowstone caldera boasts a kaleidoscope of hot springs, bubbling mud pots, and steaming vents. These hydrothermal features are fueled by the heat emanating from the caldera's magma chamber, which lies just a few miles beneath the Earth's surface. As water percolates through fractured rock layers, it is heated to temperatures exceeding 200 degrees Fahrenheit before erupting in a dazzling array of colors and textures. You definitely don't want to be anywhere close to receiving this eruption. One of the most mesmerizing sights in Yellowstone caldera is the Grand Prismatic Spring, a massive pool of turquoise blue water ringed by vibrant bands of orange, yellow, and green. Stretching over 370 feet in diameter, the Grand Prismatic is the largest hot spring in the United States and a testament to the otherworldly beauty of geothermal activity. The volcano that formed the Yellowstone caldera was one of the most cataclysmic volcanic events in Earth's history. The dark history of the Yellowstone caldera began roughly 640,000 years ago. It was the culmination of 3 monumental eruptions over the past 2.1 million years, each more powerful than the last. The first of these eruptions, the Huckleberry Ridge eruption, took place around 2.1 million years ago and created a caldera spanning more than 60 miles across. The second, the Mesa Falls eruption, occurred 1.3 million years later, forming the Island Park caldera and the Mesa Falls Tuff. However, it was the most recent event, known as the Lava Creek eruption, that gave birth to the Yellowstone caldera we know today. This last cataclysmic eruption ejected an astounding 240 cubic miles of rock, ash, and volcanic gases into the atmosphere, blanketing vast areas of the continent with ash and altering the global climate for years to come. The sheer magnitude of this event is almost unfathomable, with the ashfall capable of burying cities and farmlands, disrupting agriculture and infrastructure on an unprecedented scale. Recent discoveries have revealed that there are 2 magma chambers beneath the caldera, with the deeper chamber being 4.5 times larger than the first. These chambers are filled with molten rock, which fuels the geyser, hot springs, and mud pots. When you think about the magnitude of the creation of the Yellowstone caldera, you cannot but wonder what would happen if such eruptions happened today. Interestingly, there has been a recent increase in the seismic activity within the park. With hundreds of earthquakes recorded in a matter of days, the increase has reignited discussions about the potential for a future eruption. The scientist in charge of Yellowstone has stated that the region usually has a swarm of seismic activities from time to time. A 3-month swarm of about 2,400 earthquakes occurred between June and September of 2017, with some getting as high as 4.4 in magnitude. Scientists have begun monitoring the park's seismic activity closely and with bated breath as concerns are rising among the public and experts alike. At the heart of this concern is the caldera. The chances of a catastrophic eruption are considered low. However, the recent seismic activities observed in the region have brought about a closer scrutiny of the region's geological stability. The volcanic history of the region provides valuable insights into its behavior. This makes it slightly easier to predict the timing and magnitude of future eruptions. However, that doesn't mean it would be totally accurate, according to Yellowstone experts. While seismic monitoring and geospatial analysis offer valuable tools for tracking changes beneath the Earth's surface, the complex interplay of geological forces makes accurate forecasting a formidable challenge. Another challenge is the inability of experts to predict the type of eruption to expect. There is a potential for various eruption scenarios, ranging from minor steam explosions to full-scale volcanic cataclysms. As news of the recent seismic swarm spread online, social media platforms began to buzz with speculations, concerns, and even apocalyptic predictions. The collective consciousness of the public was stirred in a way that revealed the deep-seated anxiety and fascination with this slumbering giant. Many users expressed doomsday sentiments with a touch of dark humor. Others believed that it was the final stage in the global climate challenge that we face. Still, others believe that if the eruption wipes out only a small part of the world, the others won't escape the sulfuric downpour from the large amount of ash in the air. Amidst this widespread panic, the United States Geological Survey, USGS, and the Yellowstone Observatory served as the voice of reason and scientific grounding. They reminded the public that seismic activities, while concerning, did not necessarily point to an imminent eruption. This reminder helped to provide perspectives rooted in scientific data and expert analysis. Yet despite these reassurances, an eruption could mean a cataclysmic event for the world if the history of this region is anything to go by. In the event of a volcanic eruption at Yellowstone Lake, the surrounding landscape would be transformed into a fiery inferno as streams of molten lava cascade down the slopes of the caldera. Communities nestled in the shadow of the park would be at risk of destruction, with their homes and livelihoods consumed by the relentless advance of the lava flow. The impact of such devastation would be felt for generations to come, restructuring the very fabric of life in the region. As this ruin unfolds, the furnace would release a torrent of ash and debris into the atmosphere. This would blanket the surroundings in a suffocating shroud. Cities hundreds of miles away will remain in darkness for days or even weeks. The sky would be cloaked in darkness, blocking off the sun. These fine particles would infiltrate homes, respiratory systems, and possibly waterways. If this happens, we might be dealing with a significant threat to public safety that we have never had to handle before. This would have a severe impact on the global climate. It would inject sulfur dioxide and other toxic gases into the atmosphere, which could trigger a phenomenon known as volcanic winter. This phenomenon happens when sunlight is blocked from reaching the Earth's surface, leading to a temporary cooling of the planet. This cooling effect would disrupt agricultural patterns, trigger food shortages, and worsen existing environmental challenges, further amplifying the impact of the eruption on a global scale. In the aftermath of this devastation, communities would face the daunting task of rebuilding and recovering. Emergency responders would spring into action, providing aid and assistance to those displaced by the eruption, while scientists would work tirelessly to monitor volcanic activity and mitigate the risk of future eruptions. While these may seem far-fetched, geological history has shown that sleeping giants can wake up. One notable seismic event that shaped Yellowstone's landscape was the Hebgen Lake earthquake of 1959. This terrible event serves as a poignant reminder of the power and unpredictability of the Earth's tectonic forces. August 17, 1959, was a quiet day until a violent convulsion in the Earth shattered the silence. The Hebgen Lake earthquake rocked the region with a magnitude of 7.3. The effects of the earthquake were devastating, triggering massive landslides, rupturing roads and bridges, and claiming the lives of 28 people. This quake destroyed the Hebgen Dam, which unleashed a torrent of water that flooded the terrain, forever altering the course of the Madison River. The quake's epicenter was just outside the park's western boundary. Within moments, the ground started to undulate like the waves of a turbulent sea, unleashing unthinkable chaos. It left the Madison River dammed, creating a new body of water, now known as Quake Lake. Geysers that were formerly dormant suddenly began erupting with rhythmic cycles. Roads and bridges were rendered impassable, and buildings were destroyed. Amidst this chaos and destruction, the communities rallied together and helped to rebuild in the aftermath. This event serves as a haunting and sobering reminder of the importance of preparedness and vigilance. After this event, there was a comprehensive re-evaluation of the region's vulnerability. This led to significant changes in monitoring efforts, building codes, and emergency response plans. Knowing the kind of impact this event could have on the globe, it is commendable that there are groups of extremely talented scientists working tirelessly to ensure that we are on top of this situation, not just for the good of the United States, but for the world. Scientists and researchers from Yellowstone Volcano Observatory, YVO, and the University of Utah Seismograph Stations, UUSS, are working to monitor and mitigate the risks the park poses daily. Their efforts, fueled by a combination of cutting-edge technology and unwavering dedication, form the backbone of our collective defense against the forces of nature. These two institutions are tasked with tracking the subtle movements and seismic rumblings that betray the restless slumber of the park's volcanic system. Using a network of seismometers, GPS receivers, and other monitoring devices scattered throughout the park, these organizations provide real-time data and analyses to alert authorities to any signs of impending volcanic activity. The Yellowstone Volcano Observatory is a collaborative effort between the U.S. Geological Survey, the University of Utah, and the National Park Service. It is the primary hub for monitoring and research on Yellowstone's volcanic activity. The team consists of experts specializing in geophysics, geochemistry, and geology. The observatory plays a pivotal role in providing timely warnings to the public and emergency responders. The University of Utah Seismograph Stations operates a network of seismometers throughout the region, tasked with detecting and analyzing seismic activity associated with volcanic unrest. By monitoring these subtle vibrations and tremors that precede volcanic eruptions, the team can provide valuable information on the inner workings of the system. The team of researchers has developed a comprehensive monitoring plan focused on two key areas: backbone monitoring and hydrothermal monitoring. Backbone monitoring refers to the network of seismometers, GPS receivers, and other instruments deployed to track subtle movements of the Earth's crust underneath. Monitoring these changes in ground deformation and seismic activity enables scientists to detect signs of volcanic unrest and assess the likelihood of an eruption. Hydrothermal monitoring is the process that closely observes the park's many hydrothermal features, including geysers, hot springs, and fumaroles. These features are fueled by the heat emanating from Yellowstone's volcanic system and are sensitive indicators of volcanic activities. By observing the temperature, water chemistry, and gas emissions of these systems, scientists can detect signs of hydrothermal unrest and assess the potential for volcanic activity. Despite this robust system, experts continue to work on innovating monitoring for the future. As monitoring technology advances, scientists are exploring new ways to enhance our understanding of Yellowstone's volcanic system. This will increase our ability to predict and mitigate the risks of volcanic activity. From the development of unmanned aerial vehicles, UAVs, equipped with thermal imaging cameras, to the integration of artificial intelligence, AI algorithms for real-time data analysis, the future holds endless possibilities for innovation in volcano monitoring. However, these innovations are not without their challenges. From the logistical hurdles of maintaining and expanding monitoring networks in remote and rugged terrain to the inherent uncertainties of forecasting volcanic eruptions, the path forward is filled with obstacles. Mapping and executing observatories in this region requires that scientists navigate treacherous trails and traverse rugged landscapes in their quest for data. It is also an incredibly delicate balancing act to maintain and expand the monitoring network in this region. From the procurement and transportation of equipment to the deployment and servicing of monitoring stations, every step of the process could become a logistical challenge if not handled properly. Scientists have to rely on helicopters, snowmobiles, and other specialized vehicles to reach remote monitoring sites. They also contend with harsh environmental conditions, including extreme temperatures, fierce winds, heavy snowfall, and unpredictable weather patterns. Weather is a constant threat to the monitoring equipment and the lives of personnel. Harsh winters can bury monitoring stations beneath layers of snow and ice, while summer storms can wreak havoc on delicate instrumentation, leading to frequent maintenance and repair. You may also be surprised that a monitoring center working on such an important project still grapples with limited resources and funding constraints. This is due to the high cost of equipment procurement, deployment, and maintenance. When coupled with the ongoing need for research and analysis, this quickly stretches the budget to its breaking point, forcing scientists to make difficult decisions with scarce resources. This means that monitoring networks are regularly stretched thin, with gaps in coverage that can leave critical areas vulnerable. Fortunately, through collaboration, innovation, and unwavering dedication, the scientists and researchers can overcome these challenges and continue to safeguard the natural wonders of Yellowstone National Park for future generations. This is why the scientific institutions monitoring Yellowstone Lake have forged collaborative partnerships and innovative solutions to overcome the obstacles posed by remote and rugged terrain. They have gone into joint research initiatives and techniques. Scientists are also working together to find better and safer ways to navigate the park. While conducting this research, scientists at Yellowstone Park stumbled on a puzzling observation. There might just be an intricate dance between nature and wildlife. Among the many inhabitants of Yellowstone National Park, few are as iconic or enigmatic as the bison. These majestic creatures roam the park in search of food and shelter. It appears that beneath their seemingly calm exterior, bison are sensitive to the subtle shifts and tremors that ripple through the park's geology. Recent studies have revealed a fascinating connection between the behavior of bison and the geological activity beneath Yellowstone Lake. In the days leading up to seismic events, researchers have observed unusual behaviors among bison herds, including increased agitation, restlessness, and migration away from areas of heightened geological activity. Bison herds were observed moving away from the shores of Yellowstone Lake and towards higher ground, seeking refuge before the instruments could pick up unrest. These behavioral changes, though subtle, serve as potential warning signs of impending volcanic unrest, offering valuable insights into the intricate interplay between wildlife behavior and geological events. For scientists who have been studying this phenomenon, the bison behavior serves as a powerful tool to understand the complex dynamics at play beneath the surface of Yellowstone Lake. By carefully observing and documenting the movements and behaviors of bison herds, researchers can gain valuable insights into the underlying processes driving volcanic activity and seismic unrest. Understanding the consequences of this intricate web between wildlife behavior and geological events will help us to recognize the impact of volcanic unrest far beyond Yellowstone Park. From the displacement of wildlife populations to the disruption of ecosystems and food chains, volcanic activities may be reshaping our world in ways that we have yet to discover. As we move to understand the connection between wildlife behavior and geological events, we should be able to harness nature's wisdom to inform our efforts toward a sustainable future. Does this mean that we should abandon equipment work worth hundreds of billions of dollars and begin to study bison? Only time and more research will tell. However, experts have stated that incorporating wildlife monitoring can be an essential strategy in our volcanic monitoring efforts. By leveraging the collective knowledge and expertise of scientists and wildlife experts, we can develop proactive measures to protect human and animal populations from the potential dangers of geological events. It just might be true that the wildlife senses seismic activities long before humans can, and they migrate accordingly. It appears that we are helpless at the raw power and untamed beauty of Yellowstone Lake. It is a reminder of the delicate balance that sustains life on Earth. It is also good to remember that in the face of uncertainty, some stand as guardians of the caldera,